Okay, so on the podcast today, I'm very, very excited to welcome Miss Gabrielle Fundaro. Welcome, Gabrielle. How are you?
I'm great, thanks. How are you?
I'm good. I'm good. So we're going to be talking about all things gut health and maybe go off on a few different tangents here and there, but mainly we're talking about gut health. Now, people out there will know that there are many, shall we say, gut health gurus, so-called gut health experts. So I figured we'd bring on someone who knows what they're talking about. And I'm not going to call you a guru or an expert. I'm going to go for gut health educator. I don't know if that's a good phrase or a bad phrase, or you want to refer to yourself as something else. But I'll let you give the listeners a little bit of an intro into who you are, what you're about, and kind of how you've landed up here, I guess.
I, first of all, absolutely love that title. I am pretty adamant about avoiding the use of the term expert and certainly guru. I like to say I'm a gut health educator or gut health science communicator because I've had, the opportunity to do research in the field, to work as an assistant professor, and now fortunately to travel to deliver the best evidence-based recommendations that I possibly can from a combination of those experiences, formal education, and background. So the way that I got into gut health or the gut microbiome was actually sort of a happy accident when I was in grad school. The original project that I was working on fell through because of some issues with some samples. And so my side project, which was looking at the potential protective role of probiotic supplementation during high-fat feeding, then became my main project. And so I was able to work on that. Fortunately, finish dissertation and everything, which is the goal at the end of, a 5-year stint of research. And from there, I actually didn't do much in the gut microbiome for several years. I was fortunate to find an assistant professorship position in exercise science. And so I taught sport nutrition, anatomy and physiology, some of the intro exercise science courses. And then in my last year there, I was recruited by Renaissance Periodization. And with them, I performed primarily sport nutrition coaching. And it wasn't until I shifted to coaching full-time and left academia that I was really able to leverage my educational background in the gut microbiome to deliver, I think, a unique point of view in this area, one that I pride myself in being pretty pragmatic and skeptical, sticking to the basics and trying not to make overstated or overhyped claims, which I think is different from what a lot of people do when they want to capitalize on, all of the unknowns of the gut microbiome.
100%. And to start things off, I think a good place to start is kind of just where you finished off there in terms of the whole topic of gut health has really come to the fore in the last few years, I would say. And that leads to other people jumping on bandwagons who may not really know what they're doing or what they're talking about. And that leads to products and all sorts of different sort of things getting out into the public domain. So let's sort of try and start back right at square one, because what does gut health actually mean? What are we talking about when we say gut health? It just seems to be a term that we've accepted. I'm not sure everyone understands what it means.
I wish I knew what it meant, because I'm right there with you that it's sort of an amorphous term. And because it doesn't have a specific meaning and it can kind of mean whatever a person wants, they can use it to sell products or coaching or whatever else. So usually even when I'm, talking about the type of coaching services that I provide, I talk more in the with verbiage like digestive comfort. Because to say something like gut health, it just doesn't have a clear meaning for a few different reasons. So for one thing, when we talk about the gut, that's separate from the gut microbiome. So the gut microbiome that's so hot right now, those are all of the microorganisms that live in our digestive tract. Whereas the gut is a whole really organ system. It's a whole gastrointestinal tract that runs from mouth to anus and has a number of different cells that make up different tissues, that make up different organs. And so when we say something like gut health, where it's like we're talking about an entire country. It's not just one thing. We're talking about the area and all of its inhabitants. So, how do we save the rainforest? It's sort of like that. It's not just one thing. It's a number of different working parts that all fit into gears together and influence one another. So when people are talking about gut health, they're probably referring to a few different things. They could be talking about just their digestive comfort. So does it feel like I'm digesting my food and it goes in one end and out the other without any sort of uncomfortable gas, bloating, bowel movements are solid, how they should be, and they happen, a few times a week. So that could be one aspect. Or are we talking about just avoidance of gastrointestinal disease, if possible? Now, some of them are going to be autoimmune. Others might be something that could be, related to lifestyle, like colorectal cancer. So we can talk about the function of the gut. How is it working? We can talk about the structures of the gut. Are there any sort of ulcerations or diverticula that shouldn't be there? And then when we talk about the gut microbiome, those microorganisms, that's a completely separate topic. Of course, it has a huge impact on the anatomy and physiology of the gut. But now we're talking about all of the microbes present there. Are they a representative in an ideal sort of relative abundance? So we have mostly good or neutral guys and a little bit of the bad guy, because we do need to have, a balance in the force. We need to have, a higher representation of what would be considered to be beneficial or neutral, but we do need to have some potentially pathogenic bacteria in there, because just like any ecosystem, we can't make sort of moral judgments about who's good and who's bad. We need to have prey and we need to have predators. It's the same way in the gut. And then, so looking at that, we can look at who's there. We can look at what they're doing. So are they, functioning in the way that is supportive of host health and metabolism and immunity, or not? And so the problem there when we're talking about gut health is that, if it sounds like it sounds complex, it is. There are a lot of moving parts there. And if we mess with one, we're probably going to influence another one in ways that we don't entirely understand yet. So when people say something like, it's good for gut health or fix your gut health, I really have to kind of ask the same question. Well, what does that even mean? What part are you talking about?
Yeah. And so in terms of like the researcher, obviously you come from an evidence-based background. What does the research look like in terms of, let's say gut health for now, because that's what people understand, even though they don't understand. So how is it still very much in its infancy? Do we know a lot from an evidence-based point of view? Are we just finding out new things all the time? And so how does that influence how firm or not you can be with any recommendations and things like that?
Oh, we are absolutely still learning new things all the time. There are some really significant obstacles and sort of, blank spots in the literature, because the methodologies that can be used for studying the microbiome are so varied, and there's no specific gold standard for the way that every lab is going to do something. So something as simple as just identifying which microbes are present. Well, we have a variety of techniques with which we could do that. And if one lab uses one technique and another lab uses another technique, even if they're analyzing the same set of samples, they're going to come up with different data. Now, that could be just looking at just who's there. What about when we're trying to look at, what are they doing? So genes being expressed and metabolites. That's another layer of complexity and another layer of potentially heterogeneous findings because of different methodologies. Then when you throw in things like which model we're looking at, mice, humans, dogs, every species has a specific microbiome and a specific core microbiota that are going to be found in that species, and they're going to impact any other microbes that are present. So even if we were to do something like a transplant from a human to an animal model, the animal model doesn't directly represent a human microbiome. Taking it just to humans, Well, each human has an individual microbiome that is like a fingerprint. So yes, we do have a core that's pretty stable from human to human, but then we have on the fringes a good majority of our microbes that are going to be individual to us. So there's a great deal of inter-individual variability. And
Mm.
that's just looking at who's there, and potentially what they're doing. Then when you throw in things like lifestyle factors, so diet, physical activity, cohabitation, geographic location, all of these play a role in shaping our microbiome as well. And so when we do some sort of intervention, we also have to do that within the context of realizing that we're not ever going to have a homogeneous population. So those are just some of the obstacles. We also find that within the research, we have sort of a replicability crisis in that either things are not easily replicable, or people try to replicate them and it just doesn't happen because they're truly too unique findings. And obviously we also have a positive publishing bias. So things that show no difference are not as likely to be published. That being said, there are some good systematic reviews that are coming out that are able to point at some general themes and trends that seem to repeat themselves. And that's where we get some of the basic recommendations of doing things like eating a diverse variety of plants. That is consistently correlated with increased microbial diversity. And we see that even in intervention studies where we put individuals on a diet that is very high in plant matter. They see a positive change in diversity. Generally, an increase in diversity is considered to be a good thing. We see the same correlations with individuals who are physically active, that they tend to have greater microbial diversity. And then we see some trends associated with chronic diseases, that whether it's something autoimmune like inflammatory bowel disease, or something that's lifestyle related like type 2 diabetes, that we notice that there are unfavorable changes in these microbial communities, either a loss of diversity or perhaps an overabundance of pathogenic bacteria or a loss of beneficial bacteria. But even the dysbiosis doesn't look the same from person to person. So we see these trends, but we're still pretty much in the dark on what they might mean, and very far and away from trying to determine causality between the microbiome and various diseases.
Hmm. Yeah, so I think the around the types of diet. Well, I want to come back to that a little bit later. The other thing that you mentioned was sort of like the fingerprint analogy that you had there. Is it fair to say then that do we know what good looks like, and does good, whatever that may be, vary hugely between individuals, or is it like a small percentage that individuals? Do we not even know that? Yeah.
That's such a good question. So good looks like it depends on where you live. So we have been able to culture fecal samples or measure the genetic material by various means in fecal samples from individuals in different parts of the world. So in various parts of Asia, Africa, United States, South America. And we find that with it, even though they're all considered to be healthy controls, they generally don't cluster together. So it looks like location and ethnicity have a pretty significant impact on the overall diversity and sort of the top-down snapshot of all of the microbes that are present in an individual's gut microbiome. Mm. And that could be due to, the combination of factors. Obviously, there's going to be lifestyle differences, dietary differences, differences in physical activity, but there may also be sort of an evolutionary impact as well. Microbes are passed primarily from mother to offspring via vaginal birth. And so we can see that those are carried from, mother to offspring in humans and in rodents. And as the mother's diet changes, so too does her gut microbiome, and then so does the microbiome of the offspring. So there's another theory that perhaps in westernized cultures, we are actually sort of chronically dysbiotic. So because a lot of us are eating a diet that is deficient in fiber, lots of refined carbohydrates, not physically active, that we have we were just existing with reduced microbial diversity. And we see that that's the case when we compare our microbiomes to those of individuals who live in more rural or agrarian societies. They generally have increased fiber intakes and increased diversity, to the point where there are microbes in those individuals that are not found in individuals from developed westernized cultures. So good is absolutely relative. And when we talk about a kind of a healthy gut microbiome, there are a few things we look for. Diversity would be one. So that means that there are a large number of species, that they're not too closely genetically related, and that as I mentioned earlier, the relative abundance is supportive of host health, immunity, and metabolism. But the physical activity habits and diet can really have a measurable impact on the shape of the microbiome as well. So what is a healthy diet? That's another thing that is sort of subjective. So yeah, healthy is absolutely relative, just like dysbiosis is relative. There's no specific profile of what would be considered a healthy gut. We just know that there are some microbes that probably should be present, because they're present in all humans. But even those, we're not able to identify every species of bacteria that's in the gut. And we are actually still discovering a new species just in the past couple of years, there's been a couple, kind of landmark realizations of, oh, wow, there's this microbe in the gut and it does this pretty important thing.
Cool. So you mentioned a little bit there about different types of diets. So let's maybe kind of drift on to talk a little bit about that. So you can't really go on social media for more than 30 seconds before you see a new diet or someone pushing something on you. So you've got like carnivore diets, you've got keto, you've got all manner of different things and different ways of eating, high carb, low carb, fat, or whatever.
Yes.
Does some of these diets create an opportunity for poorer gut health or gut health issues more so than another diet?
Oh, I love the way you put that, an opportunity. Absolutely, because, oh man, I just can't get over that. I'm going to steal that from you. I'm going to say that these diets provide an opportunity.
Copyright.
Yes, absolutely. So, yeah, I'll just always quote you.
There you go.
Yeah, so absolutely an opportunity or a predisposition toward unfavorable changes in diversity. We could say that, that could be considered dysbiosis, even though there's no specific profile for dysbiosis either. The trends that we see thus far would be related to the overall contribution of fat to dietary intake, calories from fat, and the intake of fiber. Those would be probably the most significant influences that we can identify thus far. We have looked in limited studies at the role of protein and specific types of fats in modulating the microbiome. But there's very little data out there on those or on the direct impact of refined carbohydrates on the microbiome. So I would say that the strongest conclusions that we can make thus far would be that if you habitually take in a very low fiber diet, that generally leads to reductions in beneficial bacteria, specifically bifidobacteria. May also lead to reductions in the production of butyrate, which is a beneficial short-chain fatty acid. It may also lead to the reduction of the protective mucus layer of the large intestine. If we take it out to the extremes, we do find that really high levels of saturated fat intake specifically, but an overall high fat diet is also associated with increased intestinal permeability, which allows for more leakage of specific endotoxin that can bind to receptors kind of ubiquitous in the body, but specifically on skeletal muscle, and may induce insulin resistance and metabolic dysregulation. And so that was actually the focus of my dissertation, and we found that pretty consistently in mice. Now, it didn't happen to the same extent if the mice or humans foreseeably maintained a normal body weight, but if that high-fat diet was associated with obesity, it was very, very consistent in the literature that we would see those sort of perturbations. So that's one potential problematic area. So very low fiber, very high fat intakes, probably not ideal. So we do see that, with some of the extreme diets, like if a person's eating a ketogenic diet and they're not really eating sufficient fiber, or certainly on the carnivore diet. What I think is kind of funny about that is, people will say that they feel improvements in their digestion in that they don't have, any gas or bloating. Well, that is arguably due to the fact that part of the reason that we get some gas and bloating is from the bacteria fermenting fibers. And, they produce short chain fatty acids. They also produce gas. And so it's not necessarily a bad thing to have some gas production. It's normal to have some bloating. It's a sign that you have live microorganisms metabolizing nutrients inside of your body, and they're benefiting you as they do that. So I would say, arguably, eating a diet that's completely bereft of fiber, not great for the gut microbiome. So those would be the biggest things in terms of, fiber, and then fat intake. There was a pretty interesting study recently, and they compared fat intakes at, I believe, 20, 30, and 40% of daily calories. And they really found that at 40%, there was a significant change in diversity. And this was in humans. So that's kind of where that number comes from, of, kind of a 40% cutoff, probably want to keep it below that. And then getting dietary fiber in. So there have been some studies in athletes, and, they generally are associated, physical activity is generally associated with increased diversity. But in a group of bodybuilders that were eating really, really high fat diets, like over 100 grams per day, they saw that as fat increased in the diet, levels of bifidobacteria decreased. Now, these are in physically active, healthy individuals, but they were taking in only about 15 grams of fiber per day. So once again, the importance of fiber, I don't think, can be overstated. Then in terms of, other of protein as a macronutrient and its influence, really not clear yet. In mice, it looks like different sources of protein may be more or less obesogenic. And then when we look at, like I said, direct effects of refined carbohydrates, we're not really sure yet, but we just know that those carbohydrates are taken up by human cells in the gut, and not really, there's not any leftovers for the gut bacteria. So anything that we can absorb in the small intestine, that's going to be ours. We're taking those resources. We need to have some leftovers that are going to reach the colon in the form of fiber. So those are really probably the biggest take homes would be, eat your veggies, kids.
Mama was always right.
Yes.
So in preparation for this podcast, I put a few questions out to listeners. One that came back was someone had heard that specifically dairy was an issue in terms of, let's use the phrase, gut health, and that had a negative impact. Is that any truth to that? I know you kind of mentioned there about sort of high fat, so maybe there's a link to dairy there. I don't know, but is there anything specifically around dairy?
I think that's really popular right now because there's like myths about, specific like A2 casein being inflammatory or something. So now dairy is like the new bad guy. Dairy is inflammatory and whatnot. On the contrary, what we find is that, people are really, really big in fermented foods right now. The type of fermented food that we have the best evidence for in terms of its modest but consistent benefit would be dairy. So fermented dairy like kefir and yogurts and things like that, those seem to be slightly beneficial in terms of reducing all-cause mortality, perhaps promoting good body composition, and then serving as a substrate or energy source for bacteria because they contain lactose. Now, the fermented dairy is going to contain a little bit less lactose because we are adding bacteria to it, and they're actually metabolizing that in the actual food matrix itself. So by the time we're eating it, if we have a little bit of lactose intolerance, having a fermented dairy will actually might lessen the lactose load. So it'll be a little bit more digestible for us. So that's what we find is that, in fermented foods, it's a little bit more digestible because some of those carbohydrates that may be problematic to us are broken down. Now, if you are lactose intolerant, that means that you don't produce the enzyme lactase to break down the lactose sugar in dairy. eating dairy will cause you to have some gastrointestinal distress. So you'll have gas and bloating, maybe some diarrhea. It will pass. It doesn't mean that you have a dairy allergy, just that you're not producing that enzyme. And so the lactose is instead going through to your large intestine, where it's being acted upon by those bacteria. It's great for the bacteria. They're really happy about it. So if you're thinking more about your microbes than, your roommates, you can have some dairy and like get a little farty and you'll be okay. But not to say that you should go out of your way to do that, because it's super uncomfortable. But dairy in itself is not going to be problematic unless you have an actual dairy allergy.
Okay, cool. So that probably then leads us on to talk about, we've talked about various different things in terms of gut health and things like that, but also like coaches, gurus, whatever you want to call them, with their leaky gut healing diets or whatever it is that they come up with.
Yes.
So assuming that's just absolute nonsense, are there any sort of supplements or products? I know you mentioned kefir there that actually are beneficial. I know that people talk about probiotic yogurts and things like that. Is there any evidence to that? Should people think about it? Is it just minutia that's not worth worrying about?
Well, I would say, so one thing to think about for anyone because yes, there are applications for probiotics, but just like we have kind of that food pyramid, there are like lots of fitness pyramids right now. I would say the base of your fitness pyramid for the gut microbiome would have to be sufficient fiber intake, would have to be a plant-centric diet. Because even if you're adding microorganisms, guess what? They need to eat. And so if you're adding a bunch of microorganisms, which arguably may not even happen with probiotic supplementation, but assuming that happens, they're going to be competing for resources. So real estate, they might want to hang out in the center of the intestinal tract, what we call the lumen. They might want to hang out in the mucus. If there's not enough of a mucus layer because you're not eating sufficient fiber, they're not going to have a home. Then, okay, they've set up residence there. Now they need to have nutrients just like we do. So you're not going to add a bunch of animals to an environment and then not feed them. Same thing with the gut microbiome. So you have to make sure that you're supplying your microbes, your pre-existing microbes, with sufficient nutrients. So having a plant-centric diet, engaging in physical activity, having those bases covered, managing sleep and managing stress. Once that's taken care of, if you then have a specific pathology, then it may be warranted and justified to take a probiotic. So probiotics have fairly limited applications in improving human health. They can help with the symptoms of irritable bowel syndrome. They can help with the symptoms of inflammatory bowel disease, and they can help with diarrhea associated with travel, antibiotics, or C. diff. That's really about it that we have strong evidence for. Everything else, the evidence is super weak or just doesn't exist at all. So if you do have one of those potential problems, then you'd have to take it a step further and look at the specific strain of probiotic that's been shown effective with that specific pathology or malady. Because the effects of probiotics are extremely strain specific, to the point that a specific strain of Lactobacillus rhamnosus is actually only effective in pediatric diarrhea, consistently effective in treating pediatric diarrhea. You give it to an adult, does nothing. So don't throw away your money trying to buy just a kitchen sink probiotic that you think you're going to take every day. Go find the one that is going to help with whatever issue you have, and then take that. How much do I take? Well, that's the other issue with the literature. Again, we have this reproducibility issue, and we have just heterogeneity in study design. But it looks like it probably needs to be at least 5 billion colony-forming units once or twice a day for max effect. So if you're taking something that's got a proprietary blend or just like 1 billion CFUs, it's like taking 1 gram of creatine. Why would you do that? That's not an effective dose. You're literally just wasting it every day. So, buy the thing that's going to help you and use it accordingly with correct dosages. So yeah, probiotics, I would say, have an application. When it comes to constipation, if an individual has chronic constipation, it looks like the best recommendation now, based on the evidence, like Cochrane reviews and things like that, would be psyllium husk, which is just a fiber supplement. But that being said, a lot of fiber supplements can be quite gas producing, and you can have fiber sort of a Goldilocks thing. If you have too much or too little, you can get constipated. So, that's one thing that also has to be used prudently. When we look at the effects of fermented foods, they really seem to be pretty minor. Like I said, those effects are fairly modest. And really, we only have strong evidence for inclusion of dairy. The fermented grains, so there are fermented grains, fruits, veggies, even meats, just not a lot of data on what those might actually do, aside from making them a little bit more digestible for us. So, if that's something that you enjoy and want to include in your diet and helps you increase your plant intake, absolutely, sure, that sounds great. But in the things that are so popular right now, really lack evidence and even like mechanistic opportunity to cause any changes, like people taking collagen peptides for gut health or bone broth for gut health, digestive enzymes. That's another big one. There are really limited applications to digestive enzymes, and really the effective ones are going to have to be pharmaceutical grade. So most of what you're buying over the counter is going to be dosed insufficiently for actually helping with digestion, and it may also lack an enteric coating. So if you get it just like in a powdered form, like greens powders are really popular right now, and they're going to contain some a proprietary blend of like probiotics, digestive enzymes, and whatever herbals. Well, those digestive enzymes are made of proteins, and guess what? Proteins are denatured once they hit the stomach. So the vast majority of those digestive enzymes are going to enter your small intestine looking just like any other dietary protein, unfolded and partially broken down. Probiotics, again, if we don't have a sufficient dose, that's going to be ineffective. If we just are trying to take, a kitchen sink probiotic for nothing in a healthy individual, tons of studies, I'm talking like dozens of studies with multiple dozens of treatment arms have shown that in healthy individuals, probiotic supplementation does nothing, literally, absolutely nothing. So if you're already healthy, there's nothing wrong with you, you're eating a plant-centric diet, you probably don't need to be supplementing. And then if you are supplementing, I hope that you're eating a plant-centric diet to feed those bacteria. So that's the long and short of it. There really are not, and we also have to be very careful about extrapolating from cell culture studies. I know there are a couple cell culture studies out there looking at collagen peptides being added to media and modulating tight junction protein expression. That does not mean that if you as an individual take collagen peptides that it's going to do anything to your tight junction proteins, or that they need any help at all. Because that's like the mechanism behind leaky gut. You have reduced tight junction protein expression, although I'm not sure people even know that. But it's just another area that, I think manufacturers, marketers, influencers capitalize on what people might not know and try to tell them, even though it's wrong.
Yeah, 100%, 100%. Then one other thing that is a hot topic, whether it's talking about gut health or something completely different, and that's artificial sweeteners.
Oh, yeah.
So are artificial sweeteners the bad guy when it comes to the gut, as well as seemingly everything else that we talk about nutrition?
I know. So I just made a post on artificial sweeteners on my Instagram, and I have, spoiler alert, another one coming up because people were asking about like stevia and sugar alcohols. So part 2 is coming up. So get excited for that. And it's going to be actually 2 slides also, because there are quite a few sugar alcohols out there on the market. So artificial sweeteners, I think there's a couple things that we have to remain cognizant of. One thing is that, the dose makes the poison. So when we look at the potential negative effects of artificial sweeteners, yes, they exist if you have far, far more than the acceptable daily intake. And the acceptable daily intake is usually about 40 to 60 packets, or about 10 to 17 cans of soda per day, for a person who weighs about 150 pounds. So if you weigh more than that, you can eat even more. If you weigh a little bit less, you could have a little bit less. But still, I don't think that many people are running the risk of approaching, 30, 40, 60 packets of sweetener per day. That being said, if you are, realize that is still calculated from animal models, and it's still hundreds of times lower than the actual dose you would need to cause any sort of issue. So you're still going to be okay. Now that's in terms of, human health, but when people are talking about things being potentially carcinogenic or affecting metabolism or hormones or things like that. When we look in the gut, when we look in the human gut, I should say that. Now, when we look in cell culture, yeah, we can influence those cells to do a lot of things with various physiologically irrelevant doses of artificial sweeteners. So we kind of can throw that stuff away. That's just mechanistic. Now, in rodent models, we see slightly lesser magnitude of response, but still a greater response than what we see in actual human data. So in humans who are fed artificial sweeteners, no, there's not going to be a response of gut hormones to those artificial sweeteners. The other area that people get concerned about would be insulin resistance. There was a really popular study that came out, I want to say maybe in the last 2 years, and it illustrated that some individuals did experience some changes in insulin sensitivity after taking in, the ADI of saccharin, I believe it was. And interesting, super compelling, but guess what? That was a subgroup of individuals. It was 7 individuals, and like 3 of them had a response. So are we saying that like we want to apply the data from 3 people to everyone else? Probably not. It's interesting, and we know that individuals' microbiome can actually impact their glycemic response to various foods. So yeah, there's going to be some inter-individual variability that we have to account for. But to make drastic claims about the dangers of artificial sweeteners, I think that's really super overhyped. The other thing is that we actually don't have very much data on the direct effects of any of these artificial sweeteners or sugar alcohols or stevia on the gut microbiome itself. That we have just really, in many cases, 1 or 2 human trials, and in some cases we see changes, and in other cases we don't. That could be because changes are actually occurring or not, but it also could be because of the methodologies that we're using to identify change. Some are more sensitive than others. So what do we know about artificial sweeteners in the gut microbiome? Not a lot, certainly not enough to say that they're going to cause any damage from what we know thus far. And not enough necessarily to say that they're 100% safe at any dose, but they're probably way bigger fish to fry. And when we look at sort of direct effects on how we might feel day to day, it's not really like the aspartame and the sucralose and things that would have an impact. It's going to be the sugar alcohols, because sugar alcohols actually have kind of what's called a laxative dose. So it's above this specific amount, you will experience a laxative effect. And there is evidence to show that if you have really rapid transit, like if you have chronic diarrhea, that will impact the diversity of the microbiome. So if you're eating things that are giving you chronic diarrhea, that's going to be probably more problematic directly than the thing that you're eating itself, like at a lower dose that's not giving you diarrhea.
Got it. And I wanted to ask you another sort of listener-based, it was not necessarily a question, but a comment. Mm-hmm. And it was to do with basically I'll paraphrase the whole, the question. It's to do with, it was very long. It was like about 4 Instagram messages.
Oh, wow.
So I'll paraphrase.
Okay.
It was related to what impact does the meal frequency have on digestion? So the comment being that is more meals per day creating more sort of work and overload for the digestive system and more digestive stress on the body? And if so, does that actually matter? And then the second part of the question was, well, does having a meat-based diet increase that level of stress because it's more difficult, more taxing for the body to digest that meat rather than if you were just eating a plant-based diet? So if that makes sense as a question, I don't know.
Yeah. I hear this question fairly frequently because I think this kind of gets back to the idea of thinking that we need to like let certain organs rest or reset. And we do this really with just like specific organs or organ systems. Like people think that we need to like detox the liver and the kidneys. We need to let our digestive systems rest, but they don't really do that so much with like the lungs or the heart, like cardiovascular system, cardiopulmonary system, you guys can just keep working, you're fine. But like, for some reason, we don't put two and two together that like these organ systems are responding to stimuli in a normal way. Like they're maintaining homeostasis, and that's what they do. And as a matter of fact, if you fast for a really, really long period of time, or you cannot take food in through the gastrointestinal tract, and everything is IV, you actually will see atrophy of the GI tract. You'll see atrophy of the smooth muscle, and that's a pathology in itself. And so we actually do want stimulation of the gastrointestinal tract, even specifically with solid foods, because even an all liquid diet can be problematic over time. So in terms of sort of digestive stress, I mean, our body is always responding to various stressors. That's how we're maintaining homeostasis or allostasis. So meal frequency in that respect, in terms of like sort of managing stress, or can our digestive system handle it, probably doesn't make any difference. That being said, can meal frequency modulate the gut microbiome? Certainly, because there are some microbes that are that have a longer lifespan than others, some that have greater energy needs than others. So if we go for a very long period of time without supplying them with any nutrients, they may die off. They may start competing with each other more aggressively. They may start to feed on our own bodily tissues, especially that mucus layer. That's a really rich source of carbohydrates for those bacteria. So, that could be one potential impact, that we are changing the landscape of the microbiome because of a delay of nutrient availability. So that's one potential thing. In some of the time-restricted feeding studies and intermittent fasting studies, in most cases we do see weight loss, which is another factor that can impact the microbiome separately from the fasting itself. And of course that has an influence on chronic inflammation and things like that as well. So it's hard to parse out whether it's the fasting or the weight loss that actually makes a difference. When we are looking at the effects of, a meat-based diet, again, that kind of gets back to the first point of a lack of dietary fiber and a lack of dietary plant intake does cause unfavorable changes to diversity. When we see an uptick in microbes that are good at degrading proteins, they are often also going to be good at degrading mucins. So they're going to, and on top of that, we're going to have an increase in microbes that may need to turn to our mucus layer for sources of carbohydrates. So if you have a diet that is really, really heavily meat-based and not enough fiber, yeah, that is arguably potentially problematic for those reasons.
Cool. When you mentioned about the wearing out your lungs thing, it reminded me of when I did Mac Nutrition Uni, and Martin McDonald had some sort of quote that basically said, relating to high protein diets not having a negative effect on kidneys. And his quote was that you don't stop exercising so you prevent your lungs from wearing out. It's not like it's the same thing.
Exactly.
Exactly. Cool. So the other thing that just coming off the back of that sort of stress, let's call it that comment, was that in terms of, let's say, specifically building muscle, like, trying to make the gains. I've heard some people talk about there being a delay between working out and then having meals, because of you need to let the stress of the body come down.
Oh, yes.
So that you can then absorb the nutrients that you eat better to make the muscle. Is that?
Yeah, so I first heard this, I think maybe last year or so, and some person was like, hey, what do you think about eating in like a sympathetic state? And I was like, I don't, like, what is this from? Who made this up? And I guess it was actually like some trainer or coach or something who's like promoted this idea of like having to eat in a parasympathetic state and not in a sympathetic state. But it's not a light switch on off. This is a dimmer switch. And these two branches of the autonomic nervous system, in many cases, share organs. So they will both innervate a given organ. And so what we find is that it's more of a dial in one direction or the other. During exercise, yes, you'll see an increase in sympathetic nervous system tone, and it does shunt blood away from the gastrointestinal tract. But that really only happens at intensities above about 85% VO2 max. That's when we really start to see delays in gastric emptying time, and we see that blood is also shunted away from the adipocytes and really geared toward, cardiopulmonary system, working skeletal muscle. So that's why we have, that's one of the reasons we have reductions in fat oxidation and utilization at those intensities of exercise. So yeah, we do see changes in physiology that could have an effect on gastric emptying and nutrient digestion and absorption. But once we stop exercising, that is corrected really rapidly. And once we start eating, we will see an increase in parasympathetic nervous system tone just because of the stimulus of seeing food, smelling food, tasting the food, getting it into the stomach. So all of those things actually start the process of digestion before we've even actually started eating the food. And once it's actually exited the stomach, which takes anywhere from 1 to 4 hours, hopefully 1 to 4 hours after your exercise bout, you have recovered from that exercise bout and you are no longer in a severe oxygen debt and short of breath, and blood is still not going to your intestines. That probably is indicative of something else. Maybe you trained a little too hard. You probably have rhabdo and you need to go to the hospital. So yeah, not a problem. But the whole like metabolic or the whole anabolic window of like getting it in 30 minutes after your workout, like if that's making you feel queasy and you don't like that feeling, you can wait a couple hours and that's fine too. As long as you don't have another training bout, in the very, very near future that day, you will still replenish glycogen, you'll still recover, you'll still see muscle protein synthesis, even if you wait a couple hours after your workout to have a meal.
Awesome. So we've gone through quite a lot over the course of the last, 40 minutes or so. So I'm going to wrap up with 2 questions for you.
Mm-hmm.
One is going to be, so someone who's listened to all of this, how do they what are some of the telltale signs that they might have some gut issues, digestive issues? And then what would be some of the real basic things that people should do in general to make sure they're as healthy as possible when it comes to gut and digestion?
Yeah. So, obviously can't give any diagnoses or anything like that. In most cases, what people think is really severe, like a problem with their gastrointestinal tract, is actually just food related. Now, if you are having chronic constipation or diarrhea, so like more than 25% of the time you're constipated or you have diarrhea, or you notice some significant changes in your stool, like it's looking really dark or looking really bright and bloody, or you're having really, really frequent bowel movements, like more than 3 times a day, and it's uncomfortable, go to your gastroenterologist. Like that's the first step, go to a doctor, not a naturopath, not a chiropractor, go to a gastroenterologist. They're specialists in the GI tract. That should be your first step. If you're just experiencing gas, bloating, and maybe some uncomfortable BMs every once in a while, or your food, sometimes people say it's kind of like a gut rot feeling, which isn't scientific in any way, but they're just kind of like, blah, I don't feel good after I eat that, I have a sour stomach. It's probably just food related. And then you would want to find a systematic way of eliminating, testing, and reintroducing foods. The most evidence-based way that we have for that is from Monash University, and it's called the low FODMAP diet. Not something that you would follow indefinitely. It is a process to get you back to a varied diet that is just low in the foods that upset you specifically. What other things that people kind of worry about that we really can't test for, quote unquote leaky gut. Intestinal permeability is something that it changes throughout the day. It's dynamic, and we don't really have great tests to determine whether you have increased intestinal permeability, nor is it a diagnosis, nor is it a disease. So that's one thing. Now with something like SIBO, small intestinal bacterial overgrowth, you have really, really severe bloating and you're an individual who might be at risk for that, like you're taking chronic antacids, then you could go to, again, a gastroenterologist and have that test done, realizing that it may not be accurate and there is no gold standard for the way that test is administered. So there are some shortcomings with that. But I always say go to your gastroenterologist first and focus on food first before you try to do any sort of crazy expensive testing. Never even bother with a food sensitivity test. IgG food sensitivity test, complete bunk. On the other side of the coin, how do we support good digestive comfort and a diverse microbiome? Plant diversity is the best recommendation that we have thus far. The number 30 plants comes from the American Gut Project. And so that was basically data collected from individuals who are a little bit more self-selecting. So they're sending their fecal samples and then, completing questionnaires about their lifestyle habits. So does it really have to be 30 plants per week? Maybe not, but I just tell people eat plants at every meal. That's fruits, vegetables, grains, legumes, anything that's not an animal. Throw a few of those on your plate at every meal. Engage in regular physical activity, not so much that you're actually having GI distress from that, but just moderate physical activity most days of the week. Manage stress, manage sleep. And aside from that, there's not much else that you can do. Your microbiome is really stable over time. You may be able to support, the fringes and bolster some of the good guys a little bit more than some of the pathogens. But aside from that, there's really no way to sort of like remodel the gut or, I don't know what other things people try to say about it, but, it just comes back to the basics every time, like eat your veggies, exercise, sleep, spend time with loved ones.
Cool. Good advice. So you mentioned that you're doing posts on social media. So if people want to find out more about what you do, follow you, get some good info from a credible source, a gut health educator, not a guru, where do they go?
Thank you so much. So I'm on Facebook and Instagram as Vitamin PhD. I also have a website, vitaminphdnutrition.com. It's really just a list of podcasts that I've been on and things that I've written. I'm not great at marketing and websites and stuff. So I apologize for that. Don't go in there with high expectations. I also have a section on gut health, really an introductory section in the RP Diet Book 2.0, and there's a link to that on my website as well. They can reach out to me on my website. They can reach out to me at GabrielleRenaissancePeriodization.com. Sort of depending on what you're into. If you want some sport nutrition advice, definitely via RP. If you want some digestive comfort advice, hit me up on Vitamin PhD.
Awesome. And I'll put some links in show notes so people, if you want to, you can do the lazy thing and click a link rather than listen to what you just said. Cool. So it's super awesome to talk to you. Lots of practical advice for listeners, no doubt. So thank you very much for your time. It's been awesome. Really, really appreciate it. Thank you.
Thank you.